Hello and welcome back. We are on Maths 5. So what I wanted to do today is to talk about intervals. You'll recall I sort of did a bit of that in previous episodes. So basically I spoke about sort of endpoints. So what I'll do is I'll define all the different intervals that we can have. So we can have open endpoints. And we're going to be using that. It basically is the same as when I said the endpoint is excluded. So open endpoints is endpoints excluded. Yeah. And that basically is going to be, use parentheses to indicate that. And closed endpoints. Endpoints included, and that notation is square brackets. Okay, so there's basically two types of endpoint that we can have. We can have bounded and unbounded. So let's do bounded first. So bounded intervals. Okay, so the first one is going to be a simple open interval. So we have open. So we've got 2 points, A and B. So if we just put the number line here, we're going to have A here and B here. And what I might do is I'm just going to carry on down, so I don't have to write A and B multiple times. So for an open, as you recall, open means the endpoints are excluded. So we could just do a little thing there. And so basically all this area, so the start point is A, the end point is B, but both A and B are excluded. Okay, so we can do half open or half closed. And we can do that in two different ways. So half open. So say we have, for this one, we have, say, so we'll make this side open and this side closed. And then for half closed, we'll make this side open and this side closed. So just the opposite. So we can see that with the A, again, we're going to have an open point there. And here with B, we're going to have it's going to be included because it's a closed interval, so it's included. Yeah, and again, all these points are going to be used. And for this one, we're going to have it like this. And this time, got an open interval there, so the point is going to be excluded. Okay, and then we could just simply have a closed interval now, like so. And that is this basically. So there we go. So there's the bounded intervals. Now for unbounded intervals, let's do those. Unbounded intervals. I'm just going to. There we go. Just trying a little gap there. Cool. Okay. So unbounded intervals. What we're going to do is we're going to use infinity here. So obviously, yeah, so we can do it like, so for instance, say we have a closed interval here. So we're going to go from A to infinity. Now, infinity will always have a bracket because there's always been an open interval because you can't close infinity because it's not a real number. So yeah, so here we'll have A again, and I may actually I'll put for these ones I will actually label them. So A again, and it's going to go off, and we could just mention that this bit is not included here to the left of A. So anything from A as a start point all the way and infinity is you know, it's not a real number, but if it were, yeah, it would go out all the way. So yeah, and then we can do the other way. We can have an open interval. So we could do something like this. We have a here, and we'll put that in there. And again, we're going to go to infinity. So then we could also approach from the other side. So say we had minus infinity, b. Okay, so for this one, actually no, I should do I'll do a closed bracket here actually. Okay. So yeah. So for this one, we're going to have b on this side. Put it there. As you can see, because it's closed, b is included, and we're going to be going all the way off to minus infinity, like so. And then we can also have an open interval for the b. So we'll have b is excluded, off it goes to minus infinity, and yeah, and I'll just yeah, so it's still going to be like yeah, so that's the point. So yeah, I mean, it's interesting because you can't really say start point as minus infinity because it's not a real number. And what other ones were there? So, oh yeah, we could also have yeah, minus infinity to infinity, and they'd have to be. So it's just, you know, it's just the whole line really. All right. So how would this apply to various statements or inequalities that we might have? Well, what it would mean is if we say something like x is greater than 10, right? Well, we can say that x is going to be. We can say the answer is it's going to be basically x can be anywhere from 10 to infinity. But and the reason we're using this interval here, so we'll recall that this is open, so it's excluded. So it would basically be, so x here, we'd have the number line, we'd have yeah, I could just put 10 there, and well, it's gonna have to be like that now. But yeah, basically it's not included 10 because it's greater than 10. Going on with this. All right, and what if we had? All right, here we go. Here's a better one. So x is going to be greater than 3 and less than greater than or equal to 3 or less than 7. All right, so what's the range going to be? Well, it's got to start at 3, doesn't it? Because 3 is included, we can put a closed interval, and then we're going to say, all right, so it's going to start at 3 there, and it's got to be, but it's got to be less than 7, so it's going to have to be an open interval there. So that's going to be the answer, isn't it? So basically, yeah, so that's basically it. So then we can say, oh, okay, it's like this. So we basically x is in this range, right? So we say, all right, well, in that case, we look at if we just ignore this on the left, we look at this, we can say, okay, so we've got a closed interval, so we know 3 is included, so we'll include 3 there. We've got an open interval for the 7, so we know that 7 is going to be open there, and we know that all this line in between is included. So if we then look at what we've got, x is greater than or equal to 3. So we can see, yep, it starts at 3. The start point is 3. It's included because it's allowed to be, because of the greater than equal sign. So therefore, we've got a closed interval, and that's good. So closed, included, and then on the 7 side, we've got an open interval, as denoted by the bracket, as denoted by the open circle there, which means it's excluded. So anything from 3 to 7 in the real numbers, excluding the 7, including the 3. And we can also do, so if x has got different values, so x might be x can be either greater than, it's either greater than 10, or it's less than or equal to -3. Let's try that. Okay, so if x is greater than 10, well, we know it's going to have to be excluding. So it's going to have to be an open interval. An open interval starting at 10. And it's going to go all the way to infinity. So we'll have an open interval starting at 10. And then we've got infinity. And it's going all the way. Or, so x, so just imagine you're given this statement here. So x greater than 10, or, so that's what it could be. So it's either from 10 to infinity, or x is less than or equal to -3. Okay, so if it's less than or equal, it can go it could be -1,000,000. But of course, we use -infinity, and that has to be open. But it can be equal to -3, so we've got to have a closed interval. So we'll put -3 there. And we'll put a closed interval here. So if we have, we'll do the line here. We've got -3 over here. So we know -3, that's closed interval, so we can have it in there. That's fine. And anything all the way here to -infinity is going to be absolutely fine. So here we can say x is greater than 10. So we've got open interval. From 10, 10 is excluded. Anything above, though, is completely fine. And of course, the open interval sort of says, oh yeah, you're going to exclude infinity, but you can't really include it because it's not a real number. So yeah, and then x is less than or equal to -3. So it can be, we've got an open interval. So we can't, I mean, -infinity is not really a number. So we've got to have it open because it can't be closed because it's not a real number. So it's -infinity. We're going to go all the way up to -3. We'll include -3, so we have a nice closed interval. And yeah, so that's sort of a little bit about the difference between bounded and unbounded, and the number line endpoints. So the open ends are going to be regular brackets. Closed is like that. You're going to, and then open excluding, it's often going to be associated with less than or greater than. Closed is included, will often be less than or equal to or greater, or great. Well, yeah. No, it depends where you're standing, doesn't it? But basically, it's greater than or less than, greater than or less than, or less than or equal to. So this is going to always be excluding, including. Okay, so I think I've spoken enough about there. I'm just going to wait a few seconds now, just so that the video doesn't cut off at the end.